Okay. All right. Welcome back. Welcome back. Welcome back. I'm supposed to. Let me just confirm if my stream is working. Just to do that. Do-do-do, 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 do-do-do. All right. Yeah. Since quite smooth, give it a like. Yep. 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 Okay. Let's see what goes on. I will just need to change something here. Sorry. I have a bit of an issue here, so let's remove that and make sure we open. Alright, so the chart is done. That's okay. So today is day 34 and it's a long time coming. My network is not good today. But hey, let's kick it off. Let's do something. My door just closed by itself. I don't know who is in the house. Anyway, so we have we have some things here. Yeah, yes, coming. So all right, so welcome back. Sorry for the little break in transition. All right, let's kick this off. I'm just going to go over what I did yesterday. So yesterday I covered um so I solved this question yet reversing a linked list, right? And I explained how the reversal is done. So you can go and watch the previous video to see how I did it. It's essentially a way to change the position of our link of every node in the linked list, right? So the head becomes the tail becomes the head at the end of the day, and every item in between you know also changes, right? Their position changes. Every node in between changes. So here's the solution for that. It's just it's not very much. So we start with a head, right? The head we've been given. So that will give us a head as an input, and then we'll use this previous. This previous is basically keeping track of an item that came, or a node that came before the node we are about to insert in our reversed linked list, right? So, and at the end of the day, we return that reverse because it will hold the last value in the original linked list as the head, right? So yeah, you can watch the previous video from yesterday to see how I did it. Now let's. So I was going to do this yesterday. I was going to cover um how to merge two sorted linked lists, but I ran out of time. So let's go ahead and do this. So here's what I started with yesterday, and um, so we have two linked lists, right? And they are in sorted order, right? So this and that, and we want to merge it to have a bigger, um, you know, a bigger linked list, but still keeping the nature of it being sorted, right? So, um, should I brought it? Sorry, I need to drink water. Let me. I'm just going to erase everything here, right? I will erase everything and start with a clean sheet. So here's how I'm going to do it. Um, just going to take everything here, delete. Let's see. Oh, we have some questions in the chat. Somebody said, "How old are you?" I'm not sure I want to disclose that. um, so sorry, I can't answer that for now. Maybe sometime in the future, I'll probably, I don't know. Um, yeah, but I'm still in my 20s basically, so that's good. Is there any other question? No more questions. Okay, yeah. So that's good. Let's keep uh going. So let's keep the train moving. Now we are giving two linked lists, right? We want to merge the two linked lists to have a single linked list. And one thing we need to um one thing that will happen at the end of the day is that we'll have a bigger linked list, right? Which means the linked list we are going to return at the end of the day is going to be a new linked list, right? It's going to be a new linked list with, a new head, right? And a tail at the end of the day, which is this last item here. But we have, an issue. The issue here is that we are not just merging these two linked lists like this, right? We are not merging them from, we are not merging the first one, right, with the second one just by concatenating the linked list, right? Like this, we are not adding them like this, but we want to do it in a way that every item, right, is sorted in the new linked list that will return, right? So which is what this image here represents. We have this first one here, right? The order doesn't really matter, provided that the current value that we are looking at is actually smaller than, you know, the value in the second linked list. So let's say we take this first linked list now, right? That's our first linked list. This is a linked list. This is also another linked list. We'll look at the first value here and compare it with the other one. Now, if these value here are the same, then, you know, or okay, in this case they are the same, so we insert one after the other, right? We'll insert the first one and the second one. But in the case where you know the values are now different, right? So this is a 2 and this is a 3. So in our second iteration, we'll look at these two values again and compare them, right? So in this case, we want to do what? We want to take this first value, right? Since it's the smaller one, and insert it before inserting the second value here, right? And we'll do that for every subsequent node in our, two linked lists, right? In order for us to have a bigger linked list like this. So it's basically comparison of values in the linked list, right? In this, I'll call this 1 and 2. In these two linked lists, in order for us to create a new linked list, right? So this also means that we'll need to start a new linked list, right, with a new head. So let's say we use this as our placeholder. This will be a first node, and this will also represent the head of our final linked list that we want to return. I'll call this what should I call this? Okay, I'll call this final linked list, or denote it with F, the letter F, right? So this will be a placeholder, right? I'll call this P. This is a placeholder, right, that represents the original state um of our final linked list, right? So this we will use this as a placeholder in order for us to, add values from this, either of these two linked lists, right, which is our input. So we'll use this, right? We'll use this, and then let's say we'll do p dot next, right? P dot next. We know to add an item to a linked list, we use the next property, and we set the next to the next linked list, right? To the next linked list here. So let's say in this case we want to use 1, right? So next will be set to linked list 1, right? Dot next. So we are giving the head of each linked list. So this will be, the next value will be the list 1 here, right? This will represent the head of this linked list. So this will look something like this. So we'll have, this will be equal to an object like this with the data set to 1, and the next value here is going to be, every other thing here. So which is why we need to set it directly to this linked list. And in this case, we still have another 1 here. So we set the next value again, right? Next to be equal to the list 2, right? But in the case where the values are now different, right? So this is 2 and this is a 3. So we'll still compare the values again. So this is how we need to first of all compare the values, sorry, before we then set it like this. So here's how the comparison will go. So this will be list 1, right, dot, the data value, right? The data is what we want to compare, right? Whether the data is superior to list 2 dot data, list 2 dot data. Then if this condition is valid, then we know automatically that list 2's value is the smaller one. So we'll take the p, right, our placeholder dot next, and set it to equal to the value of list 2, and each time we set the values like this, right, we know we need to move to the next node, right? So we'll move to the next node of the list that we just inserted to our placeholder node, right? So placeholder linked list, these words are so long to say, right? So we'll take this list 2, right, and move to the next value. So list 2 will be list 2 dot next, right? So the list 2 will be list 2 dot next. And then, you know, so in the next iteration, we are no longer going to look at the first one, right? We'll move. Okay, let's use list 2. We are no longer going to look at this, right? The list will then become every value, every node from this point all the way to 4, right? And each time we add a new value to our linked list, our final linked list, we then reset the pointer again in the second node, or the first one. We'll shift it again to the other side, right? So we'll start from 2, and then in the next situation we can start from 4, or 4 here, right? So that's how we'll be able to. Let me just erase everything here. I'll take everything out. That's how we'll be able to merge these two linked lists, right? It's just by comparing the next value, right? The data value of each node in each linked list, right? Both of the linked lists. So um I don't know. I think I should call this L1 and L2, right? So we know this is L1 is our first linked list, and L2 is our second linked list, right? So the L1 will always start from the head, right? So this will be the head of L1, and the head has a next value, which is this one here, which is 2, and 2 also has a next value, which is 4, right? And we'll do this for every node in each linked list, right? So which is what I'm doing here. Every time we insert a linked list to our placeholder, right, we then use that linked list, we then reset that linked list by setting it to the next value, right? So linked list 2 will become linked list 2 dot next, and for linked list 1 we'll do the same thing. If we inserted the data value of the next value of linked list 1 to our final linked list, or our placeholder, then we'll reset that value as well, right? So yeah, let me see. So with that, we'll iterate through the entire linked list, reset the values each time, and append um the current linked list that has a small is the smaller data value to our final linked list that will return at the end of the day. Now, returning a linked list does not mean we'll return this p entirely, right? We'll return the next value, or the head value of this linked list. In this case, we started the head with 0, so we are not going to return the head per se. We're going to return something like this. We're going to return p dot next, right? Because at the end of the day, the next value will start from where we inserted the first value of either of these linked lists here, right? So yeah, so let's go ahead and code this out and see how that work. So I'm just going to, I think I should use the part where, so basic linked list, right? Linked list basic. So yeah, I want to use this code here. I want to use this code here just because I've already implemented the linked list. Or okay, let me just I'll create a new file called this merge dash 2 linked lists. Right, we'll do merge 2 linked lists, right? And we'll set this again. So let's go ahead. So I don't want to use LeetCode's boilerplate because we don't have we don't have this optional stuff. So what do I do? What do I do? So I'll just copy. I mean, I know I'll be passing it two heads, right? So I'll just say here, um, I'll just define merge, merge two linked lists, right? And this function, you know what? It's better for me to, okay, I'll implement it here and then test it in this part here, because um I would at this point I'll be able to create some linked lists and use the head values, right, in my new implementation. So here's what I need to do. So so the parameters my function would take will be two heads, right? So I'll have head, uh okay, let me say linked or list one, yeah, list one and list two. So those are the values my function will accept. And so we need to create a, so I'll call this placeholder, right? So placeholder placeholder I'll call this placeholder node, right? And set this to be equal to we need an instance of a node. So I'll quickly create a node class here, class node, and set this to be equal to define dash init. We need a value, and we need to set the data. So I'll say self dot data to be equal to this value here, right? And self dot next will be equal to none. Okay, so then we now need to create a placeholder for our node, right? And yeah, so we'll begin iterating through we'll begin iterating through both lists, right? So we'll start here. So we'll say while list one and list two, right? Meaning while we are not at the end of these lists here, right? So we can continue iterating through the list. So we'll do something like this. So if list one dot data, sorry, if list one dot data is superior to a list, okay, let's start with list two. Okay, so if list one dot data is less than list two dot data, right? So if list one has a smaller value, right? So we can do something like this. We can say the placeholder dot next to be equal to list one, right? This one, and reset list one now to the next node. So list one should be equal to list one dot next, right? And then in the case where it's not, then we'll just need to do list two, sorry, placeholder node dot next, placeholder node dot next to be equal to list two, and then we'll reset list two to our new node here. So list two will be equal to list two's next node. So oh my god, list2 dot next, right? So um here's how this will work. So let's say we have mm, you know what, let me quickly implement a linked list class, right? So this will even help you know remember how a linked list class can be implemented. So linked list, I'll call this linked list. Linked list is made up of nodes and so we need an instantiation function, or another word, a constructor, right? So we don't need to pass it any value, but we need a head for our linked list. So I'll say self dot head, right? Self dot head is going to be equal to none at first. Sorry, this is going to be none, and then we can we can define a function to add add node, right? I'll call this add node, and this will take a value this time around, so I'll call this val. And what does this value do? Well, first of all, we need to instantiate our node class here, so I'll call this new node, and new node will be set to node dot value, right? So, and then we'll check if we already have if if our if self dot head, right, if self dot head is none, then we need to set a new head to the current node. So self self dot head, right, self dot head is equal to new node, and then we return here. So we return. Otherwise, if there is already a head, right, we need to traverse the head. So I'll do something like this. So I'll first of all take that head, right? I'll say current node is equal to the head, right? Self dot head, right? And then current node is equal to self dot head, right? It means we're setting the current node to head. So while we have a head, right? While current node is not none, right? While the current node is not none, then we need to set the current node to the next node. Current node is equal to the current node dot next, right? Dot next. And at the end of the day, we might reach a point where the current node is actually has the next value of none, right? We've already set it to the last node here. So what we need to do is to just say current node, right, should be equal to new node, right? No, sorry, current node dot next. Yes, should be new node. All right, that's okay. And yeah, so let's see. Oh, sorry, I was in the wrong place. Let me just remove this quickly. I don't know why this is always that it should be lowercase. I mean, I choose to do it this way, so ignore errors like this. Yeah. Okay, so this is how we'll add uh a new node to our linked list, right? So, and at the end of the day, we want to return the linked list, blah blah blah. So, okay, so let's try and see if we can add. Let's try and see if we can add. Oh god. Let's try and see if we can add a new node to our linked list. So I'll just say, let's create a linked list here. So I'll say const. Oh wow, the time has really gone. I need more time. I need more time. So let me put like 25 minutes more, right? I don't know why time is. There's like a huge spike in time speed these days. So be careful out there. So I'll call this. Whoa, I don't know why I kept this open. Somebody must have been like, just close the sidebar, close it. Okay, so I've closed it now. Um, so let's. I think I'm becoming short. Um, anyways, so let's try and add new items to our linked list. I'll create an list. I'll say new. Okay, I'll call this list one. List one. And set this to linked list. What did I call this? Yeah, linked list. Linked lists, right? This is an instance of a linked list. I'll create another list again. List two, and set this to be equal to linked list again. So these are separate instances. So we can begin to add items to each linked list. So for the first one, I'll do linked list one dot add, right? Add node. I want to add one, right? One, and then I'll do this one. Let's say I want to add 4 items to this linked list. So instead of, I'll put 1 3 okay, 1 3 4 and 5. Okay, so for the second linked list, right? linked list, sorry, list 2 will do list 2 dot add node. We'll add these nodes here. I'll just copy. Okay, so I'll add a 3, right? Okay, let's do it this way. What were the values we were giving here? So it's 1 2 4 and 1 3 4. 1 2 4 and 1 3 4. Let's go back to this place. 1 2 4 1 3 4. 1 2 4. So we don't need the fifth one, and 1 1 3 4. So I'll say 1 2 4 and 1 3 4. 1 2 4 1 3 and then 4, right? So let me write a function to print out the items in the linked list, right? So I'll say so let me just use this same class, right? Sorry. So define print linked lists, or just print nodes. Yeah, let's call it print nodes. Again, this would take the head, but we don't need to do it because we are implementing it in the class, right? So let's say First of all, we want to set when we are printing every item in a linked list, we need to start from the head always. So current node again is going to be equal to self dot head, right? And then I'll just say while current node, right? Sorry, while the current node is there, so while current node, what do we do? Our current node is not none, right? We need to print current node dot next, right? And as usual, we'll add the end, so we'll have everything on the same line, right? So like this, and then we'll say current node is equal to the current node dot next. All right, so here's what we need to do, and I'll print this first linked list here. So I'll say print, oh sorry, I'll call the function, so linked list 1 dot print nodes, right? I don't need to pass it any value. I'll do the same thing for the second linked list. Linked list 2 list 2 dot print nodes, right? So let's see what goes on. Oh, has no attribute of next. What's going on here? So we have node 2, node 1. Where is this error from? Current to the last track. Blah 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 blah. So we have current node dot next. Online, what's line 18? Oh, okay. Line 18. What's happening? Let's see. We have here add item node return. Oh, I see. Sorry, if this dot next is not none. My bad. I see. Something funny is happening. What's this? I want to print the node dot data, not next. Sorry, that's my bad. Node dot data, right? Okay, so now this is correct. We're supposed to have none at the end. Unfortunately, we did not. So current node dot next, node dot data. I mean, we should see the none, right? If we're printing next, then we would have seen none. But anyway, this is not bad. So I even did an implementation at this point. Insert value. Oh, come on. Insert value. Reverse print. You know. That's cool. I'll just to print this second one now. This will print everything on the same line, which is not something I want. So I'll print a line separator here, right? Print this, and we'll have them on separate line. Oh, how do we solve this? I'll just do print empty string. Yeah. Okay, so we still have the same value because okay, these are not the same. So we have 1 2 4 and then 3 1 3 4. Okay, these are our two linked lists. Now we want to merge these two to create um one, right? So we did this here, right? I'm just going to return something here, right? Return placeholder node dot next and see what is going to happen. So I'll call this merge two linked lists. I'll put list one dot head and list two dot head, right? So let's see, um you know, instead of returning everything, I'll just print here, print. I mean, this is doing print again. Another new. I want everything to be on a new line. Okay, so here's what we have. We have, I think this return the head, right? So let's say we want to print this. You know what? I can define another function outside. So I'll just copy this function here. I just want to see what's inside the merged linked list at the end of the day, right? So here I'll call that function, right? Merge to linked list. So here I'll say merged is equal to this, and I'll pass the merged into this. So print what's it called? Print ll, print linked list, and pass it merged dot head. Dot head like this. So let's see what's merge dot head. I mean, merge will return us what? Oh, merge is already returning a value, right? So we don't need to. Oh, it's returning 4. Why is that? Why is it returning 4? Only 4. I mean, we are supposed to have a list of every node, right? But we are getting just the last node. And the reason why that is happening is because, right? It's because of the way, oh, I see. It's because of the way we are reassigning. So we are just setting this placeholder the next, right? We are setting the next value only. Meanwhile, in this case, you can see we always add, we always update our node, right? Current node will be the next value. So let's say at the end of the day we did something like this. So placeholder node, right? After doing this, right, we need to say placeholder node is equal to placeholder. I'm not sure this is going to work due to how values are copied by reference and so on. So let's see what's going to happen. Yeah, see, this is returning none. So what if we keep a copy that traverses the actual node here? So I'll just say copied node, right, and set this to the placeholder node. And instead of using the placeholder node to do this, I'll just use the copied node, and yeah, so use the copied node each time. copied node. So copied node will update itself. So copied node here, and then we have copied node. Okay, so with this, the placeholder node and the copied node will start with the same values, right? 0 to none, right? Data value is going to be 0, and then the next value is going to be none. But at this point here, we will update the next value of the copied node, right? And by updating the next value here, this placeholder node gets automatically updated. So at the end of the day, we'll have our placeholder node set to whatever value is next, the next copied node is going to be. So let's run this again. So now you can see we have 1 1 and then 2 3 4. Okay, so there's a bit of issue, right? The items are not complete. We are supposed to have, oh okay, this is complete actually. Oh, sorry, this is complete. I thought we had 2 twice. Okay, so this is working, right? And this is working because of how, you know, because of how values are copied by reference in Python, right? So we have so here we both copied node and placeholder, right? Placeholder node are the same. They are pointing at the same address in memory, right? So this, if any change happens to this copied node here, right? If any change happens to this, then the change will also reflect in this place, right? So which is so in the first iteration, right, we set copied node dot next. Automatically placeholder node dot next will also be set to the value of list 1, right, which is the head, right? And then, you know, the same thing happens here, but when we reassign copied node dot next, right, when we reassign copied node dot next, ideally this would have broken the connection between placeholder node and the copied node, but because copied node is still copying, is still referencing the value of our original copied node, right, the connection is still there, right? But this time around we're just saying copied node shouldn't keep track of every previous node, right? It should just keep track of the next node, right? This is, let me just show you what's happening here. I will just copy. I need to, because this is very, it took me, you know, some time to actually understand how copying by reference and copying by value actually works. So let's say for instance we have an object like this. So I'll just call this you know, lists, or let's call this node, right? This is going to be node, and node is an array of value 0. And then I say you know, I'll call this placeholder, and set it to be equal to node, and what is this, copied placeholder. What did I call this? Copied node. Okay, copied node is equal to placeholder, right? So any change we make to this copied node here will reflect in the placeholder node. So let me just show you that. So print, I'll first of all print both, right? I'll say print copied, right? I'll say, yeah, I'll call this copied node, and set this to be equal to copied node, right? And comma placeholder, and set this to be equal to the placeholder node. Right. So let's just print this and see. Now you can see copied node is 0, placeholder node is 0. Let me make a change to the copied node directly. So copied node dot append. Let's say I want to append a 5. Okay. I said 5 and I pressed 4. So when I append 5, what you imagine is, copied node will have values of 0, values such as 0 and 5, right? But because copied node is a copy of the placeholder node, the changes that happen to the copied node itself will reflect in placeholder node, right? Or the placeholder itself. So let's just run this now. You see both become 0 and 5, right? So which is why when we modify a value that is copied, right, and which means those two values are reference the same object in memory, right, then whenever a change happens to one, the change is automatically reflected in the other, right? So until let's say we assign a new copied node, and when we do something like this, copied node, let's say 3 and then 5, right? You'd imagine placeholder will be equal to 3 and 5, but in reality that's not what's going to happen, right? The reason why that is not going to happen is because copied node no longer references the same object as this placeholder here, right? Which is this node here. It becomes something new, right? Which is this array here, or this list. So this changes in memory, this changes its address. So when you run this code now, you can see this is 3 and 5, but placeholder remain the same, right? Placeholder remain the same, and no matter what happens to this going forward, the values will not change unless we are specifically modifying this node, right? Let's say at this point here we do this, we say the first value, right, at 0 should become 6, right? So this will change the copied node to 6 and 5, right? So the same thing will happen to the placeholder as well. This will become 6 and 5. So which is why this works in this case. What is this? Met to node, right? So whenever we make a change to this copied dot next, right, the change is automatically reflected in this placeholder node here, right? And yeah, so don't worry about this. This is basically telling the copied node to keep only the next value that it has, instead of just continuing with the with whatever was here, right? So this is just for us to keep track of the next node, instead of creating a bigger node from this point, from the copied node. So yeah, at the end of the day, we are returning the placeholder node dot next because our head here is 0, right? We don't want to return placeholder node just like this, right? We need to return the next value, right? Because 0 is just a placeholder, and we don't want to return 0 as part of our node. If I remove this, right, you will see we'll start from 0, right? 0 will be our head, and we did have 0 in either of our lists here. So we need to return the next value here instead, right? And this way we'll have our correct node. Now in the case where our let's say we have more items in one node than the other, what's going to happen? So let me just copy this. Let's say we had a 5 here, or instead of 5, I'll just put 11, right? When we run this, right, we don't see the 11 as part of our result, right? We need the 11 as well. So it means for every value that is remaining, we need to append it to our linked list, right? So I'll just do it like this. So instead of printing this, I'll just remove this here. So I'll say if list, sorry, if list one, right? It was in list one I did that, right? Okay, if list one is still remaining, then just set current, sorry, not current, I'll say copied node to be equal to list one, right? And yeah, same thing for this one. So if list two, then just set copied node, sorry, copied node dot next, not copied node, copied node dot next, copied node dot next to be equal to list two. Yeah, so let's run this again. Now you can see we have our 11 at the end, but we have this twice, which is wrong because that's not what we want, right? Is it? If list 2, is it? I mean, we are resetting this here, so we know the values are not empty. Okay, so if list 1 is not none, right? Should I do it this way? And this is not none. It's still happening. So what's going on? What's going on? Copy node dot next. Wait, hold on. This is still coming up twice. Or do I have? Oh, I forgot I had 2 for values here. Sorry. Oh, Christ. Brain. Okay, so I think, let's say I'm adding more items to list 2. So I'll do list 2 dot add, let's say 44, and list 2 has dot add 70, right? More items. So how do we do that? Yeah, so this is correct. Okay, so let's go ahead and implement this in LeetCode and see what we will have at the end of the day. So let's go. Merge two linked lists. Merge the two of the linked lists here. So we'll do current. Sorry, we'll say placeholder. Oh, why did I write this? Placeholder node, right, is going to be equal to list node, right? List node, at least that's what they referred the node class as, list node. So list node, and set it to equal to 0. And what happens next? So we'll do something like this. So we say oh, so we need a copy. I'll call this copied node, and set this to equal to the placeholder node. Placeholder node, and just run my while loop. I can just take this, right? Let me just copy this. I don't need to waste time. So print, add node, copy node. Yeah, so I'll just copy. Oh, I see what's going on. Oh yeah, we use this one and this two here, so that's cool. That's just okay. So I will just shift this in and copy node. Let's see. Oh, so there's placeholder. Oh, placeholder is small h, placeholder node. This one, the data. Oh, they are not using data here. They are using what? Val. Okay, so val. This one dot val, and then here dot val. We have list one. This nice. Yeah. Okay. So let's run this. So these have been accepted, which is good, but this doesn't mean the submission will be okay. But I'm pretty sure it will work because, yeah, it's okay. This should work. Alright, so show submit. And I would like to, after solving this question, okay, this worked, this is fine. There are also similar questions. After solving these questions, right, I would go ahead and start, you know, document, I mean, putting them in an Excel sheet and close this. So here's my Excel sheet, right? I'll do something like this. So let me copy this node and add a note each time I solve a question. So I'll say linked list. This is not the first linked list question I have solved. So one thing I need to do is to, so question, I'll just put, this should be one, right? I don't think I need this column basically. I don't need it. Question ID for what? I don't need it, but I might need the title, right? So I can select everything here, like all the way down. So I'll just increase, sorry, format, height, row height. Let's set this to like 35. Okay, so this is better, right? So what's the title of the other question? I think the one I solved yesterday was what was this? Reverse linked list. So I'll do something like this. This is very good for revision and every other. Oh, sorry. We need this here. You know what? Before I even do that, I can, say format row height, set this to 30, 33. And also, I want everything to be. No. This is okay. I want the words to be word wrap tests. Yep. So so when I post an error here, it will wrap it, but this is not good, right? Because now it's just is how do I do this properly? I'm not an expert in, well, I think I should just remove the word wrap, right? I don't know. Okay, I think I've removed it now. So when it goes like that, I can just increase this, but it shouldn't go more than, it shouldn't be more than this. So the title of this question was reverse linked list. So I'll copy this. It's LeetCode 206. So copy tests, right? What's this? Copy. I hope you didn't copy the. Okay, so reverse linked list, and this is an easy question, so I'll just put easy here, and the status is solved. Attempt was, I'll just leave this, I don't need this, right? What's attempt? Okay. Oh my god, what have I done? Okay, I'll just put like this. Time. Oh my god. Okay, so let's leave it like that. Time taken, I'll leave it. The date I solved this. Do I really need this information? Do I really need all of these information? But the most important thing here is the note, right? The note. So time taken here, attempts. Attempts can be covered in time taken. So I mean, if it took me 5 hours, then it means I must have attempted it a lot of time and failed. So yeah, I did recall these, right? Because I saw them. So this is linked list. So I'm in linked list. Note here is that how did solve this, right? First of all, we to reverse a linked list, I'll just say starts. So we start from the head. So start from head, right? And no, start from head and set a previous 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 value that updates a set of previous value, okay, to none, right? Come on, I don't like how do I make the height dynamic in Excel? Does anyone know how to do that? Can you show me the question for once? The question is in the description. You can get it in the description. So it's already there. Very nice. Where are you from? I am from Nigeria. Yeah. Okay, so I'll just do this. I'll wrap the word. So wrap it. Wrap tests. Yeah. I mean, I I format row auto. Oh, okay, yeah, that is good. That is what I wanted. So if I did this, right, uh, set the value to none, right, that's number one. Number two, if I hold shift like this, okay, there are two steps, right? So I'll just do this. Iterate the nodes and set the current and set the start, right, to the current node's next value and to the next value, and the previous previous becomes I mean the current node value. I mean we start with the we set the current node's next value. No, iterate the nodes and set the current node's next value to what? To the previous, right? To the previous, and the current node to the previous, right? We set the current node value to the previous, the right current node value to previous. So I just put like this. Okay, that's not gonna work. To the previous, previous value, right? So set the current node's value, next value to the previous value. Update the current node to the update the current node to update the current node. Okay, let me just say update the next node by setting its value to the current node's next value, right? So the current node's next value update previous to the current node. Yeah. So yeah, so this is what we do. I think instead of me set, so I'm just coming. Let me adjust this quickly. So I set everything, and I need to do this. So everything should start from the top, right? That's good. I mean this. Oh, to start from the top. Height is auto fit row. Okay. And instead of this, we can reduce this width. This is just okay. Let's keep it like this. I mean, you can say format width, auto fit column width. Okay. Oh no. This is not good. Or if I did it this way, then I'll just that's not good. Alright, so I'll do this for every other question I had solved, and I'll start sharing this with everybody. Okay. Bye. Oh, I need to push this to GitHub. So here's what I need to do. So I say, even yesterday's one, I didn't push it. Let me push yesterday. Git. This will not work. Git. Will it? Okay. Git push origin. Wait, I did. Oh, git push origin. Origin main. Right. Okay, so I'll then do git add for today's on git commit -m um merge two linked lists, right? Git push origin oh main. Okay, so with this everything was fine. You can get the solution, my solution, from GitHub. The link is in the description below. So enjoy your evening, and we'll meet again tomorrow for day 35. All right, ciao.